we got tonight?
More of the same stuff. Preparing for a test tomorrow.
Okay.
So, given the interval of 0 to 2 pi, I need to solve 4 cosine squared equals 1 plus 4 cosine.
Yeah. Gonna call you, William?
Okay. Okay.
Oh man, it's always such a relief. All right. What we're looking at here is a quadratic. Okay. It's the most important thing you can realize is that you're looking at a quadratic in cosine of x. As long as you understand that, then let's solve it like we would a quadratic in x, which is to put everything on one side and then try to factor it. Well, I know the signs have to be opposite, and that being the case, 2 cosine x and 2 cosine x is not going to work. So let's begin with 4 cosine x and cosine x. I still don't think it's going to work. Even if I put it's 1 and 1 is all we've got. So I could make that plus 1 and that minus 1. But that still doesn't get us to that middle term. So that leaves us with only one thing to do. Quadratic formula. Now, the question is, why would they give you something that required the quadratic formula? All right. First of all, do you understand why this is a quadratic? Okay. If you did not, we could do something like use substitution. And if you're ever in doubt as to whether something is a quadratic, make sure you can do use substitution, which would basically give you this. Now it looks like a very normal polynomial. And we can't factor that either, but let's solve it using the quadratic formula. What do we got?
Positive 4 plus or minus the square root of negative 4 squared minus 4 times 4 times negative 1 all over 2 times 4.
So what's u equal to? 4 plus what? What's the discriminant going to be? In other words, this amount. Okay, good. So square root of 32 all over 8, and it's plus or minus. And then let's carry that forth. So we get u equals 4 plus or minus, I can take a 16 out of that, so that's 4 root 2 all over 8, which means u is equal to 1 plus or minus root 2 all over 2. With me?
Yeah,
And u is cosine of x. That's what we let u equal to.
So what you did there was you factored out a 4 and then simplified.
Well, yeah, I divided top and bottom by 4. That's all I did.
Okay.
Now, cosine of x is equal to this. Well, let's check both answers to make sure that both of them can be possible. Well, 1 plus 1.41, all divided by 2, is a number that's greater than 1, correct?
Right.
Well, cosine of x can never be greater than 1. So that answer, no good. We cannot violate the range of cosine of x. Cosine of x has to be between minus 1 and 1. If we take the other number, now we're inside the range. In other words, that's approximately negative, what, 0.2? In other words, I'm not concerned with preciseness at this point. I'm concerned more with whether in other words, a lot of times when you have a quadratic, you produce two solutions and one of them is extraneous. And particularly when you're dealing with trig functions. So you always have to be on the lookout for that solution that's greater than the number 1, which was our first solution. Second solution is between minus 1 and 1. So this is the only solution. Okay? So now we come down and we've got cosine x is equal, do you mind if I round everything off here? I don't really want to spend time getting down to hundredths place.
No, that's fine.
We'll call it that. Okay? Now what's x equal to? Tell me what x is equal to, because all we figured out was what cosine of x was equal to.
Do you want me to calculate it?
Yeah, put it in your calculator. Because you have to know the quadrant also.
Right.
If
It's 78.5 degrees.
78.5?
Yes.
That would be the first quadrant. In other words, if I said cosine of x was equal to 0.2, the answer would be 78.5. But if I say cosine of x equals minus 0.2, that puts it in the second quadrant. So what's the equivalent angle of that only in the second quadrant?
Uh, 101.5 degrees.
That's the answer. And it's not a bad idea on these problems to go back up and check. 101.5 degrees. Now, hold on a second. I lost sight of the fact that the domain was the unit circle. Okay, so there's probably two answers. Where is the cosine negative? Well, it's negative in the second quadrant, but it's also negative in the third quadrant. So what's the equivalent of 78.5 degrees in the third quadrant? 258.5. No, hold on. Yeah, I added 180 to that.
Okay, right.
That's all I did, okay? So there's actually two answers. There's this answer and there's also this answer. And if you check both of those answers, 258, this will be true. This equation checks out with either one of those answers. Let's do 258. What's the cosine of 200? Make sure you're in degrees. What's the cosine of 258 degrees?
Negative 0.2.
Square that.
0.04.
So now we have 4 times 0.04. Is that equal to 1 plus 4 times the cosine? Which one did we use? 258? That's not true. Oh, maybe it is true. Cosine.
Yeah. It with the rounding
it is true. What's cosine of 258?
Negative 0.2.
So 4 times that is 0.8. Yeah, okay. So at least we're in the ballpark. Yeah. In other words, we're within round-off error. Okay, which means we're correct. Because if it was something wrong other than round-off error, we'd be a lot further away than we are. So whenever you're testing these and you get something that's really close, it's safe to assume that you're looking at round-off error. Now, if you also checked 101.5 degrees, you should also get. In other words, the cosine of 101.5 is the same as the cosine of 258. They're both negative, and they're both the equivalent angle of 78.5 degrees. So these cosine of each of those angles is the same, which means that both of them are going to check out in that equation.
Right.
Now, the only reason we had to do both of them was because of this right here.
Right.
Had they not specified that domain, well, I would have likely just stuck with the second quadrant angle. And that's not really correct either, but yeah, let's do another one. I'll show you what I mean.
Okay.
What's the next one?
Cosine of 2 theta plus 5 cosine of theta plus 3 equals 0.
Domain restrictions?
Yeah, the same, 0 to 2 pi.
Okay. The one secret of solving trig equations is you got to get everything in the same equation, in the same trig function. In other words, if I got a mixture of sines, cosines, and tangents, I can't solve it. If I got a mixture of cosines and tangents, I can't solve it. If I've got all cosines or all tangents, I can solve it. So we got to use one of our basic trig identities and turn that into something. What should it be?
2 cosine squared minus
That's why they give you 3 identities for cosine of 2 theta. It's because frequently you need all 3 of them, depending on the nature of the problem. In other words, had this been sine theta instead of cosine theta, the thing after the 5, then I wouldn't have used that identity. I would have used the one that had sine squared in it. Only.
Right.
Okay? Only sine squared. In other words, 1 minus 2 sine squared theta is the identity I would have used. So the one you use depends on the reason you need to use it. Now, because I use this identity, I'm now looking at a quadratic.
Okay.
Quadratic, again, in cosine of theta. That's what that's called. It's not a quadratic in x. It's a quadratic in cosine of theta. Now, boy, there's just no excuse for them making us use the quadratic formula. This one better, factor, okay. Does it? Now, let's not use U substitution this time. Let's do it. Let's do it. We don't need U substitution here. We can separate that. One of them is going to be 2 cosine theta. The other is going to be cosine theta.
Right.
In other words, we don't have to go to the effort of doing U substitution. What are both signs going to be?
Positive.
What are my factors of 2?
2 and 1.
Clearly the 2's got to go there, the 1's got to go there. In other words, our goal is to produce a 5
Right.
in the middle. And that middle term comes from the inside and the outside terms. And then adding those 2 together. Well, when we produce that middle term, that means we've factored it properly. Okay, let's keep going. This one's a better one because they don't make us use the quadratic formula to solve it. Never understood why they do that. Tell me what the next 2 things I should write are.
Cosine plus 2 equals 0.
Okay, which leaves cosine equal to what?
Negative 2.
And the next thing I should write?
Cosine equals negative 1/2.
Are both of those possible?
No.
That one's outside the range.
Right.
There's no way, it's impossible for the cosine of theta to be equal to minus 2. Answer has to be between minus 1 and 1. Now, if I had a 14 in front of that, that'd be different. You know, then 14 cosine theta could go all the way up to 14 or all the way down to minus 14. But without anything else, the flat cosine of x is limited between minus 1 and 1. So that is an extraneous solution. Now let's figure out theta. Where is the cosine of theta in the unit circle? Where is it equal to minus 1/2? The easiest way to do this is to start with where it's equal to plus 1/2.
Pi over 4.
Pi over
pi over 3.
3. Okay. However, that's not minus 1/2. However, that's a good starting spot. Okay, what quadrants do we need to be in such that the cosine of theta would be minus?
2 and 3.
Okay, what's the equivalent second quadrant and third quadrant angle of pi over 3?
2 pi over 3 and 4 pi over 3.
That's our 2 answers.
Okay.
Okay. Now, if they'd have not restricted the domain and they'd have said go from negative infinity to positive infinity, we'd have to come up with one of those series using n or k. I can't remember which one you guys use. But use k, okay. The fact that they restricted it to one unit circle makes the problem a lot easier. In other words, is all we have to do is find the two quadrants where this is true. And there's almost always two quadrants. The one exception is if it's equal to 1 or minus 1. Then there's only one answer. In other words, if I said cosine of theta is equal to 1, the only answer is 0 degrees. Or if I said minus 1, the only answer is pi. But when you have any number other than 1 or minus 1, you're always going to have two quadrants where it's true. Cosine's positive in the first and fourth, but it's negative in the second and third. So when we see cosine of theta equals minus 1/2, we know our answer is going to be in the second and third quadrants. And I did it the easy way. Figure out the first quadrant first, knowing that that's not the answer, but that's the easiest way to figure out the second and the third quadrant. At least to me it is.
Right.
I kind of tend to do everything in trig relative to a first quadrant angle. All right, what else do we got?
Without the use of a calculator,
Okay.
find the exact value of tangent of 10 degrees divided by cotangent of 80 degrees.
Okay. You familiar with cofunctions?
Yes.
Okay. So we know that tangent of x is equal to cotangent of 90 degrees minus x, and vice versa. And I know I'm going to use this property because I can see the relationship between 10 and 80. 10 and 80s add to 90. So I know, and besides that, the first thing you think of when they give you the tangent of 20 degrees, I have no way of getting that without a calculator.
Right.
That's not half angle, it's not a double angle, it's not the sum of two angles. In other words, I would be pretty much lost to come up with a value of the tangent of 10 degrees. So there better be something special about this problem. Well, it turns out, first of all, cotangent is the reciprocal of tangent. So I can make this statement. Hold on a minute. Is that a true statement? I guess it is. Oh, what am I missing here? Tangent of 10 degrees is in the numerator. The denominator of cotangent of 80 is equal to a numerator of tangent of 80. Now I could make that cotangent of 10. That helps a lot, actually. So, yeah, I didn't realize it. So this is going to be tangent of 10 degrees times cotangent of 10 degrees. You see how I get that?
Oh, okay.
From this, in other words, tangent of x is equal to cotangent of 90 degrees minus x. So tangent of 80 is equal to cotangent of 10. Now I've got something that looks like tangent of 10 divided by tangent of 10. That's equal to 1, no matter what the number is.
Right. Okay.
Okay. So there was a lot of things going on in this problem. The most important one probably was recognizing that those two oddball numbers
Are complementary.
well, are complementary, right. And the fact that they're oddball numbers is important. Those aren't 30 and 60 or 30 and 45 or anything that we know how to do without a calculator. So there must be something else going on with this problem, and it's this, the fact that they're cofunctions. And once you use the cofunction property, well, first of all, I use the reciprocal property to get that. Then I use the cofunction property to get that. Then I use the reciprocal property again to get that. And it just turns out that it works out perfect. You get tangent of 10 degrees over tangent of 10 degrees.
Okay.
Let me think if I did too many steps, because I might have. Yeah, I did. Notice, I can do all of this in one step. I didn't need to do all those steps. Let's back up a little bit. I can immediately say the bottom is the tangent of 10 degrees.
Right.
The top is the tangent of 10 degrees, and using the cofunction property, that is also true. So in one step, I get my answer. I don't have to go through all. I went through at least 2 extra steps unnecessarily.
Okay.
Okay? You know, not that it matters. Are your tests multiple choice?
No, I don't think so.
All right. Even so, even if you'd have gone through those extra 2 steps and gotten this answer, I'll bet you'd have gotten full credit for it.
Right.
I don't think you'd have lost points because it took you 3 steps instead of 1.
Right.
All right.
Okay, so this one says solve the equation analytically for all values of x and do not use a calculator.
Okay.
Tangent of theta plus the square root of 3 equals 0.
Okay. This one, theta is not limited to 0 to 2 pi. It's all real numbers. What's the next thing? What's the first thing I should do here?
Subtract root 3 from both sides.
Tell me what the first quadrant theta is. And now, you may not need to do it that way. To me, it helps. Okay? I'm going to put what the first quadrant is, and then I'm going to put an X through it. And as all that does is it allows me to figure out the second and fourth quadrant easier.
Right.
What's the first quadrant? In other words, where would tangent of theta be equal to square root of 3?
Pi over 3.
Correct. Okay, now that's first quadrant, so I know that's not right. But I need second and fourth, because in the third, tangent's also positive. So give me the second quadrant angle that's the equivalent of pi over 3.
2 pi over 3.
And the fourth.
5 pi over 3.
And since they want all real numbers, not just the unit circle, we need to do at least a couple more. What are the next 2 entries?
8 pi over 3 and 11 pi over 3.
That should be enough to figure out our series. And
Could I
here's
also
our...
write
here's our series. Let me just write them out. And you tell me how I can most efficiently write that series. And I guess I need that pi there also. Okay.
You could write 2 pi over 3 plus k pi.
Perfect. In other words, this happened to be one that we could completely write with one sequence, because each number is separated by 3. And the next one's going to be 14 pi over 3, which it is. And so, in other words, we don't need 2 different series for this. And 3 over 3 is 1, so it's k pi is perfect.
Okay.
All right.
So the next one is same directions, and it's 2 sine squared minus 1 equals 0.
Tell me what sine squared of theta. Finish this problem for me here.
Sine squared of theta equals 1/2.
Now what's sine theta equal?
1 over root 2.
Plus or minus?
Okay.
1 over root 2.
Right.
That plus or minus is significant. That's going to give you 2 more answers per unit circle. Okay?
Right.
So, let's figure out where theta is equal to plus or minus 1 over root 2. Let's lay out the first 8 answers. In other words, 2 unit circles worth. And the only reason I'm going to use 2 unit circles is because they're going all real numbers. They didn't restrict us to 1 unit circle.
Right.
So in order to see the pattern, at least for me, it really helps to lay out 2 unit circles. So what's the first quadrant angle?
Pi over 4.
Second quadrant angle.
3 pi over 4.
Third quadrant angle.
5 pi over 4.
Fourth quadrant angle.
7 pi over 4.
Sure looks like a pattern. Let's do one more.
9 pi over 4.
Yeah, that's going to now give me the equation for theta.
Pi over 4 plus k pi over 2.
Good. Okay. Now notice that k can be negative also. In other words, k is all real integers. So it goes from negative infinity to positive infinity by integers. And that works. In other words, one of those answers was minus 2 pi over 3, which was covered in your answer, that because k can be negative, you've covered all the answers on the number line with that. Okay, what else?
Secant of pi over 8 minus 1 over sine of 3 pi over 8.
The 1 is only over that, or all of it?
Just the 1.
What is it again? Sine of
3 pi over 8.
equals?
0. It's find the exact value. No equation.
Oh, okay. Well, let's see. Wow. What is this equal to? What's its reciprocal? What's the reciprocal of sine? Cosecant.
Right.
So that's the same as cosecant of pi over 8. 3 pi over 8, excuse me. Now again, notice that that plus that equals 90 degrees.
Okay.
So we're looking at the cofunction property.
Okay.
Okay, and the cofunction property for secant is the secant of x equals the cosecant of pi over 2 minus x. So what I'm looking at here is the secant of 5 pi over 8. What am I doing here? I'm messed up somehow. Let's see. I know I'm on the right track. No, it's not. It's, in other words, this is going to be the secant of pi over 2 minus 3 pi over 8, which is pi over 8. Right? In other words, this is 4 pi over 8. 4 pi over 8 minus 3 pi over 8 is pi over 8. So this whole cosecant thing right here that I got circled turns into secant of pi over 8. So I have secant of pi over 8 minus secant of pi over 8 equals 0. Understand?
Yeah.
Okay.
Okay.
What else?
Right.
In other words, the key to these problems, to recognizing the solution to these problems, is to see that that plus that is 90 degrees. And if it is, then it's probably using the cofunction property. Especially since the cofunction, or excuse me, the reciprocal of sine is cosecant, and the cofunction of cosecant is secant. So that's a good clue that I want to turn this into cosecant, and then I want to use the cofunction properties of secant and cosecant. And this works both ways up here. If the secant is equal to the cosecant of 90 degrees minus x, well then the cosecant is also equal to this. In other words, both of those are true based on the cofunction properties.
You can also make that cosecant of 3 pi over 8 minus cosecant of 3 pi over 8.
You know, unfortunately, that doesn't tell you anything. In other words, yeah, cosecant of 3 pi over 8 is equal to cosecant of 3 pi over 8, but so what? In other words, what I need to do is once I use the reciprocal property and I have this, now I need to use the cofunction property of cosecant. Well, cosecant has to be secant of pi over 2 minus 3 pi over 8, and that gives you secant of pi over 8. Now, only because they're the same, I can say that that's 0. I don't know what the secant of pi over 8 is, but I know the whatever it is, the secant of pi over 8 minus the secant of pi over 8 is 0. Okay? So you had to use two properties here. One was the reciprocal, which got me from step 1 to step 2.
Right.
And then the cofunction property of cosecant got me to step 3. In other words, this property right there, the bottom.
Right.
The cosecant of 3 pi over 8 has to be equal to the secant of pi over 2 minus 3 pi over 8. That's what gave me secant of pi over 8.
Okay.
All right. What else?
I don't have any more problems.
Trig is like a giant jigsaw puzzle. I just realized. That's why I enjoy it. I really do. It's always like solving a puzzle.
It makes a lot of sense. There's an intuitive in it.
Well, the secret to all of these, every problem you presented tonight, the secret was knowing your trig identities. Knowing your reciprocal identities, knowing your cofunction identities, knowing that trig functions can be quadratics in disguise, stuff like that. That's fine, William. We can stop now. I have no problem with that.
Okay, thank you very much.
Especially at the end of a very long week. This has probably been my busiest week in a long time. And it's just a warning to you. It's going to be like this for the next 6 weeks. So if you're looking for appointments, get them early. Or better yet, do them on Friday, Saturday, and Sunday, which I prefer. But if you're looking for appointments, I should say from Monday through Thursday, get them early. Because I'm going to be booked up, I'm guessing, every Monday through Thursday for the next 6 weeks. I'm not sure by when, but the last couple of weeks, I've been booked up by Sunday. Okay? So, just keep that in mind. All right, William. Talk to you later.
Bye. Thank you very much, Mr. Count. Have a good night.
You too.